हेलो साथीहरू, यो भिडियो जसले हेरिराख्नु भएको छ त्यो सबैजनालाई म यो भिडियोमा स्वागत गर्दछु। आजको यो भिडियोको मुख्य उद्देश्य भनेको चाहिँ मेश एनालाइसिस हो। आज हामी मेश एनालाइसिसको बारेमा पढ्नेछौँ। त्योभन्दा पहिला हामी मेश एनालाइसिसको बारेमा केही जानौँ। मेश एनालाइसिस भनेको चाहिँ के हो भने मेश एनालाइसिसको सल्युसन चाहिँ गिभन नेटवर्कबाट उसको सल्युसन कसरी अब्टेन गर्न सकिन्छ भने द सल्युसन अफ द गिभन नेटवर्क इज अब्टेन्ड इन टर्म्स अफ मेश or loop current which are assigned arbitrary for each mesh. Okay, it is the application of Kirchhoff's voltage law. अब हामी यसको यो एनालाइसिस सम्बन्धित कुनै पनि क्वेशन्सहरू सल्भ गर्नको लागि केही स्टेप्सहरू हुन्छन्। त्यही स्टेप्सहरू हामी अब पढ्नेछौँ। स्टेप्स स्टेप नम्बर 1, हामीले पहिला पोसिबल नम्बर्स अफ मेश अथवा लुपहरू फाइन्ड गर्नुपर्ने हुन्छ। जस्तै यो क्वेसनमा पोसिबल नम्बर्स अफ लुप कतिवटा छन् भने 1 2 3 है। भनेपछि हाम्रो पहिलो स्टेप के हुन्छ भने फाइन्ड द पोसिबल नम्बर अफ मेश। मेश अथवा लुप। सेकेन्ड स्टेप के हुन्छ भने assume the smallest number of mesh currents so that at least one mesh current links every element as a matter of convenience. All mesh currents can be assumed to have a clockwise direction. Next step is for each mesh, write down Kirchhoff's voltage law equation. Okay, when more than one mesh current flows through an element, the algebraic sum of currents should be used. The algebraic sum of mesh currents may be the sum or the difference of the currents flowing through the element depending on the direction of mesh currents. And the last step is solve the above equations and from the mesh currents find the branch currents. So these are the steps to be followed for finding the currents, mesh currents, and find the branch currents. So these steps should be in your mind for solving mesh related problems. And this given network, the solution of this given network can be obtained in the terms of mesh or loop current, which are assigned arbitrarily for each mesh. And I already told you that this is the application of voltage law or Kirchhoff's voltage law. Now I am going to solve this problem on the basis of these steps. And one thing I want to tell you that between two mesh current source is present. It means that this mesh, first mesh, I assumed this mesh as first mesh, this mesh as second mesh, and this mesh as third mesh. So first mesh and second mesh is super mesh because between two mesh the current source is present. Okay, so let's move towards solving this problem. So I have already told you that this is super mesh. So look at the mesh 3. Current I3 moves towards clockwise direction, and this current source also move in this direction. So solution here, we can write directly I3 equals to 2 ampere. No, I3 equals to, because mesh 3, current of mesh 3 is I3. So here I3 equals to 2 ampere. If this current was moving in left direction, then the current of the mesh 3 would be I3 equals to minus 2 ampere. But now this current is moving in right direction, so I3 equals to positive 2 ampere. Okay. Also, mesh 1 and mesh 2 are super mesh, so current of this mesh minus current of this mesh equals to 1. I1 minus I2, current of mesh 1 is I1, current of mesh 2 is I2, so I1 minus I2 equals to 1, equation 1. Now applying KVL on super mesh in both. Okay, KVL on super mesh. Okay, we get we are entering from negative sign, so write negative 8 others positive. So or another way I can also solve, so write positive. If we are entering from negative, then write positive, others negative. So minus 2, and current will be I1 minus I3, and for this 4 ohm resistor minus 4 I2 minus I3, and we are entering from positive to negative, so write negative minus 10, and here minus 6 I2, because here only I2 current flows. Okay, we have to apply KVL on this super mesh, and so when the current is entering from negative sign to positive sign, then we have to write the positive sign, and others will be negative. So minus others will be negative, so minus 2, and current will be I1 minus I3. Move towards 4 ohm, minus 4 I2 minus I3, and here we are entering from this clockwise direction. First we come to positive, so positive to negative, so minus 10, and last one is 6 ohm, so 6 into I2 equals to 0, or 8 minus 2I1 plus 2I3 minus plus 2I3 minus 4I2 minus plus 4I3 minus 10 minus 6I2 equals to 0, or I1 minus 2I1 minus I2 I2 6 4 10 minus 10 I2 I3 plus 6 I3 and plus 8 minus 10 minus 2 equals to 0, or minus 2 I1 minus 10 I2 plus 6 into I3. The value of I3 we have already calculated, that is 2 ampere. So 6 into 2 minus 2 equals to 0, or minus 2 I1 minus 10 I2, 6 to the 12 minus 2 means 10 equals to minus 10. This is equation second. Now solving equations 1 and 1 1. From equations 1 and 1 1, we can solve these two equations directly from calculator. So I am going to solve it by calculator. We will get the values of I1, current I1, and I2. These two are mesh currents. So I have a calculator, this kind of calculator. I will share the link of this calculator in my video. You can see it in the description box. Okay. We can calculate it into the mobile phone, very easy. So we have got two I1 and I2. So choose the equation. First go to mode, and we have this kind of equation here, a and x plus b and y equals to c, and this kind of equation we have here. So put the value. What is the coefficient of I1? 1. So 1 equals to coefficient of I2 minus 1, and equals to Cn, so equals to positive 1 1. Equation 2. Let's have a look into the equation second. What is the coefficient of I1? The coefficient of I1 is minus 2. So minus 2. And the coefficient of I2 is minus 10. Minus 10. And equals to what? Minus 10. Minus 10. So value of I1 is 1.67. Ampere, and the value of I2 is 0.67 ampere. Yes. Math. Okay. Now we have asked to find the current flowing through 2 ohm resistor. Where is 2 ohm resistor? Here is 2 ohm resistor. So how can we find the current flowing through this resistor? So let's use our mind. I am taking 1 minute. I am also giving you time at the same time. Okay, use your mind, I am using my mind. So time is over. uh, we can find this current by subtracting I3 mesh 3 current minus mesh 1 current. So we have to obtain the positive value. Current can't be negative. So which one is whose mesh current have magnitude is more? We can see the magnitude of mesh third is greatest. So I3 minus I1. Therefore, current flowing through two ohm resistor I2 ohm equals to I3 minus I1 equals to I3 equals to 2 ampere minus I1 equals to 1.67 ampere equals to 2 minus 1.67 equals to 0.33 ampere. This is the solution. So I have followed these steps to solve this problem. So first keep in your mind these steps to solve these kinds of problems. It will be easier for you to solve any kinds of problems related to the mesh analysis. Thank you. Bye bye.